In this video, we're going to do another application problem that has to do with exponential functions. And this problem is going to be about world population. So I went on Wikipedia and I found that the world population has been growing at a little bit more than 1% per year in recent years. In fact, the estimate that I came up with was about 1.16%. And so I found that the world population in billions can be modeled by this function. P of t equals p sub 0 times 1.0116 to the tth power, where t equals 0 corresponds to the year 2000. Now, I haven't told you what this p sub 0 is. Okay, this is just going to be a number, and we're going to find what p sub 0 is in part A. But notice where the 1.16% comes in is right here. Okay, and part A says the world population in the year 2000 was about 6.127 billion people. So 6,127,000,000 people. Find p sub 0. Okay, well, so first of all, notice that the population in the year 2000 is just p of 0. Okay, because like P of 5 would be the population in the year 2005. P of 7 would be the population in the year 2007. So P of 0 is the population in the year 2000. So notice it's 6.127. Okay, but also we can look at P of 0 by looking at this function up here, looking at this formula. P of 0 is P sub 0 times 1.0116 to the 0th power. So basically all I've done here is plugged in 0 for t. Now, of course, anything to the 0th power is just going to be 1. So what we get is p sub 0 is, or p of 0 is equal to p sub 0. Okay, well, p of 0 is 6.127 and p of 0 is also p sub 0. That just means that p sub 0 has to be 6.127. Okay, so that p sub 0 is really just the initial population, the population in that first year, the year 2000. Okay, well, notice now that we have the p sub 0, we can rewrite our function as p of t is equal to 6.127 times 1.0116 to the tth power. Okay, so I've just rewritten this function up here, down here. Okay, only now I've put in what p sub 0 is. Okay, so this is a model for population growth. If for different values of t, we can approximate the population at different years. We can plug in 0 if we want to find the population in the year 2000. We can plug in 20 if we want to find the population in the year 2020. Okay, so that's exactly what we're going to do in part B here. It says if this model continues to remain valid, what will the world population be in the year 2035? Okay, so what we want to find is what is p of 35. So let's take our model here, 6.127 times 1.0116 raised to the 35th power. Okay, so we had already found the p sub 0 in the previous video, so we're just going to use the formula we have. Okay, and I did this on my calculator, so I'm not going to show you the calculation here, but I did this on my calculator and I got rounding to 3 decimal places, I got 9.174. Okay, so what does that mean? Well, that's 9.174 billion people. That is the world population. Okay, that's if this model continues to remain valid, that will be the world population in the year 2035. Now, I should point out this is just a model. Okay, what we have here, this is a very different situation than if we were putting money into a bank account and getting compound interest and trying to figure out how much money do we have at some point in the future. We could figure that out exactly if we knew the exact interest rate and so forth. But modeling population, we're just approximating things. There's obviously things can affect the growth rate. Okay, if there are diseases or famines or wars or something, it could lower the growth rate, or other things could boost the growth rate as well. In fact, in Wikipedia, they did an estimate in the future for the population in 2035, and it's a little bit less than this. I think it was a little bit less than 9 billion. So I think they expect the population growth rate to slow down a little bit.